Hi, this is Anirudh, and today we'll be doing problems from permanent magnets as a part of magnetism. Please do follow us on our Facebook, Instagram, and Telegram channels for your daily dose of math and physics. Let's get started with our JEE problems. First question today talks about two magnets N1S1 and N2S2 are such that the angle between them is 90 degree. They are fixed at an angle 90 degree. The magnetic moment of N1S1 is root 3 times that of N2S2. They have said that if I have this fixed arrangement of these at 90 degree, what angle will this be along with the magnetic meridian of the earth? That is, we need to find this angle theta. Now the concept involved here is generally when you have a single magnetic moment, it aligns in the direction of magnetic meridian. Since you have two here, if one tries to align, the other de-aligns. So that's why the net effect, the resultant of these two magnetic moments will be the one that will align with the direction of H. So we know that the resultant magnetic moment aligns in the direction of this. So if we can find the angle between the resultant of N1S1 and N2S2 and find its angle with N1S1, then we can normally find the angle with the magnetic meridian. So let's just say that the magnetic moment of N1S1 is root 3 times the magnetic moment of N2S2. If I take N1S1 as the x-axis, N2S2 as the y-axis, then finding theta is simple. That tan theta is equal to my mx. My is your N2S2, mx is your N1S1. So m of N2S2 divided by m of N1S1, that is m of N2S2 divided by, replacing here, root 3 times of m of N2S2, cancel out, and you have tan theta is equal to 1 by root 3. Tan theta 1 by root 3 means theta is equal to 30 degrees. So for the first sum, our correct option is option number 3. Let's move on to the next. The second sum says that the magnet suspended freely has a period of oscillation equal to t. Now it is broken into two equal halves, each having length half of its original length, and one piece is made to oscillate freely in the same field. If its period of oscillation is t dash, then the ratio we need to find. So generally we know that the time period of oscillation of any magnet suspended freely in a magnetic field is given by 2 pi root over I by mb. Now we have made the length in half, but there's no mention of length in this formula. But if we look closely, length does occur in many. It occurs in the moment of inertia, it also occurs in the magnetic moment. So let's write it in terms of length. The moment of inertia, I can write, if it's long suspended rod, then the moment of inertia through the middle point is given by ml square by 12. The magnetic moment is given by the monopole moment, let's represent with P, multiplied with the length, and the B stays as it is. So now we see that it has a dependence of L. Not just that, even the magnetic moment, even the mass of the new rod, which when it is broken in half drops by half. So m dash, let be the mass of the new rod, half of the rod, that will be half of the original mass, and the new length will be half of the original length. If we do that, we can replace t dash is equal to 2 pi root over of m dash L dash by 12 P into B. From this formula out here, remember monopole strength does not change even if you split the magnet. So if you put the quantities here, you get 2 pi root over of m into L divided by 2 into 2 from each of these into 12 into P into B. ML12PB is that of the original time period, so I can represent T dash is equal to 1 by 2, 1 by 4, when it comes out of the root comes out as 1 by 2, to 2 pi root over of ML by 12P into B, that is equal to half of the original T. Therefore, T dash by T is equal to half. So correct option is again option number 3. Let's move to the next one. Generally, when we have magnetic moments, we generally have two poles. It exists as a dipole, but here we have three poles, one with positive M, and another with minus 2m. So if you want to find the resultant magnetic moment of this entire arrangement, the way to do this is, instead of treating this as one single piece, consider that this arrangement is actually two different magnetic moments, two different dipoles, minus M plus M, and another magnetic dipole, minus M and plus M, like this. So we are breaking up this 2m into 2 minus m, so that now I can have two separate dipoles such that the angle between them is 60 degree. The magnetic moment of each of the dipoles, let's represent that with P, is given by m into the distance, m into a. For each of them, they both point in this direction from the positive to the they point from the negative to the positive direction. So we can find the resultant easily if we know the angle between the two vectors. We know that the resultant is equal to root over of p square plus 2p into p cos of 60 degrees, since both magnitudes are the same. So that leaves me with p square plus cos 60 is half. So half cancels with 2. You have just another p square. So root 3 p square, that is root 3 into p. P again is my m into a. So you have root 3 m into a. So correct option is option number 1. These type of questions, especially the ones that I did in the second sum, are very important for your JEE. Cover these formulas and these concepts about how to deal with dipole moments in permanent magnets. That's it. We'll see you again in the next video. Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.